In this video, we will talk about the sum and difference formula for the tangent. How do we get the sum and difference formula for tangent? Well, we do know that tangent of any angle, theta, is equal to sine of theta divided by cosine theta. So that's basically what we're going to do. If we want to find the tangent of alpha plus beta, well, that's just going to be equal to sine of alpha plus beta divided by the cosine of alpha plus beta. Okay. Now, the good thing about this thing is that we know what the sine of alpha plus beta is using the sum and difference formulas for sine. So that's just sine alpha cosine beta plus cosine alpha sine beta. And then divided by the cosine of alpha plus beta, that's just going to be cosine alpha cosine beta minus sine alpha sine beta. Okay, so that's what I know. Now, what I'm going to do is something really, really subtle, and it probably won't make sense. You're probably wondering, how did you come up with that? But basically, what we really want to be able to do is kind of get rid of this cosine of, like the cosines on the top. Okay, and the way that we kind of get rid of the cosines on the top is just by dividing by cosine beta and also dividing by cosine alpha. So what I'm going to do is I'm going to write down sine alpha cosine beta and then plus cosine alpha sine beta on the top. Okay, we're going to do that. And then on the bottom, you're going to have cosine alpha cosine beta minus sine alpha sine beta. And basically what I'm going to do is that I'm going to divide everything by cosine alpha cosine beta. Cosine alpha cosine beta. This guy is also going to be divided by cosine alpha cosine beta. And this guy is also going to be divided by cosine alpha cosine beta. So basically what's going to happen is that you're going to get rid of these cosine betas. Here you get rid of these cosine alphas. Here everything is going to cancel. And here nothing's going to cancel. So what I'm going to be left with is the sine over cosine, which we know what that is. That's just going to be tangent of alpha. This guy right here is going to be the tangent of beta. The bottom part is just going to be a 1. And then the bottom part is just going to be minus. This guy is tangent of alpha. And this guy is just tangent of beta. So this guy is basically my solution. Okay. So it's something really, really subtle. It's not something that's that we just immediately come up with, but this is just something we just wanted to get rid of the cosines because then we will be able to get the tangents, and we don't want to be dealing with cotangents. So basically, if you wanted to get the minus, you would do the same exact thing. Here are the sum and difference formulas for tangent. They're not really difficult to memorize. So what we're going to do is we're going to do this last example. Okay, so this example is really important. You will see something like this on the exam. So make sure that you really know how to do something like this. So this one is really, really important. Before we start that, I want to be able to show you guys a couple of things before we do that. Because so far we've been using a lot of the formulas to be able to solve for certain trig functions. Now I want to show you kind of a different way to do it. So let's say your angle was in the first quadrant. If your angle's in the first quadrant, we can kind of draw the triangle as so. Okay, you can draw a triangle with whatever angle it is looking like that. That's how the right triangle will be. So it's always going to be hugging the x-axis. If your triangle is in quadrant 2, your triangle is going to look something like this. Okay, still the base is going to be hugging the x-axis. If your triangle or if your angle is in quadrant 3, then your triangle is going to look like this. So now it's upside down. And if your triangle is in quadrant 4, it's going to look like this. And this is basically based on the reference angles that we learned in the very beginning. of class. So that's just basically how you draw a triangle depending on which quadrant you are. One way that kind of reminds me is that it kind of looks like a bow. So if I draw a bow like this, right, you can see that this bow is basically a representation of all the right angles in different quadrants. So imagine that all of these were right triangles. Okay, so we have all of those. So whenever you want to draw a triangle, this is how it's going to be looking like. It's never on the y-axis. Everything is going to be on the x-axis. The base is going to be hugging the x-axis. Okay, so now, and this will be really useful for this type of problem. So the first thing that we want to be able to do, let's go ahead and read it. So suppose that sine of alpha is equal to 3/5. Here, alpha is between 0 to pi over 2. Okay, so let me box that guy. Then I'm also given that the cosine of beta equals to -5/13. And then beta is between pi and 3 pi over 2. Okay, and what we need to figure out is all of these identities: sine alpha plus beta, cosine alpha plus beta, tangent alpha plus beta. Okay, so one of the things that I like to do is draw two different triangles because I have two different angles. We want to first start off with alpha. So let's see where alpha is at. So alpha, if you notice, is between 0 and pi over 2. That tells me that it's in quadrant 1. Okay, so for alpha, if I were to draw the triangle for alpha, it's in quadrant 1 because it's between 0 to pi over 2. So our triangle is going to look something like this. And here's alpha. Now we are given that the sine of alpha is 3/5. Okay, so it's going to be 3 on the opposite and then 5 on the hypotenuse. So the other guy is going to be a squared plus b squared equals c squared. So you get a squared plus 9 equals 25. A squared equals 16. A equals 4. So that means this guy's going to be equal to 4. Okay. Now, normally, remember that because now we are in an axis, when you square root both sides, you technically write plus or minus. Now, in this case, it's not going to be minus because we're in quadrant 1. Everything is positive there. Okay. Now, let's look at beta. So for beta, let me draw a triangle. In this case, beta is between pi and 3 pi over 2. So here's pi and then 3 pi over 2. That means that my triangle is going to look like this. Remember, it's always hinged by the x-axis. So here's beta. Okay, so now cosine is going to be the adjacent over the hypotenuse. So it's going to be the 5 over the 13. Now, which one's negative? Well, the hypotenuse is just basically the distance. The distance can never be negative. So that makes sense that this guy should be negative. And that kind of also makes sense because you're in the negative x-axis, so it's going to be -5. So what would the other one be? So it would be just a squared, which is going to be -5 squared, plus b squared equals 13 squared. Get 25 plus b squared equals 169. I'm going to subtract the 25 over. So I'm going to have 169 minus 25. That's going to give me 144. Take the square root to both sides. B equals plus or minus 12. Now, which one should it be? Should it be positive or should it be negative? Well, since we're in quadrant 3, everything is negative. So we're going to choose the negative side. It's going to be -12. Okay, so I think the tricky part here is being able to figure out the signs. And the way that you find the signs is by knowing which quadrant you're going to be in. Okay, so now that we have basically our two triangles, now we can kind of use the formulas to try to figure out what all of these different trig functions are going to be. So we're going to start off with the sine alpha plus beta. So sine alpha plus beta, if you forgot what it was, you can just go back to our formulas. So this guy is just going to be sine alpha cosine beta plus cosine alpha sine beta. Okay, and now all we really have to do is just look at the triangles. Okay, so cosine of alpha. Okay, so here's alpha. Sine of alpha is going to be the opposite over the hypotenuse. That's going to be 3/5. Then we're going to have the cosine of beta. So now we're going to look at this triangle. Cosine is going to be this negative 5 over 13. Plus the cosine of alpha. The cosine of alpha in this case, so we're going to go back to alpha. It's going to be the adjacent over the hypotenuse. That's going to be 4/5. And then multiplied by the sine of beta. That's going to be the negative 12 over 13. Okay? So let's multiply this out. This will give me negative 15 over 13 times 5. That's going to give me 65. Then negative 12 times 4. That's going to give me negative 48 divided by 65. And what is this going to give me? So you're going to get negative 15 minus 48. Going to give me negative 63 over 65. So this is going to be the answer for the sine of alpha plus beta. Okay, so now we found the sine of alpha plus beta. Now we got to find the cosine. So the cosine of alpha plus beta. Okay. So again, if you forgot what it was, you can just go back up, figure out what that is, and look at it. Okay, or you can just look at the formulas. Okay, so this is going to be cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. All right, so cosine of alpha is just going to be this 4 over 5. Cosine of beta is going to be this negative 5 over 13. Minus sine of alpha is going to be 3/5. And then sine of beta is going to be negative 12 over 13. Okay, so on the top I'm going to get negative 20 over 65. On the top part I'm going to get positive 36 over 65. Okay. All right, so now I'm going to get 36 minus 20. That's going to give me 16 on the top, divided by 65. Okay. All right, cool. And now we're finally at the last one, which is going to be the tangent. So tangent of alpha plus beta. Well, that one we just figured out what that was. It was just basically this guy. So that's just going to be equal to tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta. Okay, so again, looking at our triangles, you have tangent of alpha. That's going to be opposite over adjacent. That's going to be 3/4 plus tangent of beta. The tangent of beta is going to be this negative 12 over negative 5, which is basically a positive, divided by 1 minus 3/4 times 12 over 5, which is basically a positive. Okay. So now the top part is going to be this 3/4 plus this 12 over 5. And on the top, you're going to get 63 over 20. On the bottom, you're going to have 1 minus this 3/4 times this 12 over 5. And you're going to get this negative 4/5. Okay. And then you're going to take this 63 over 20 divided by negative 4/5. And I'm going to get negative 63 over 16. Okay. All right, and that's basically how you do this problem. So basically, if you want to look at it in steps, the first step is to just kind of draw where exactly all of your angles are. So here, this is the first step, draw angles in the quadrants. And then after you've solved these triangles, okay, and then the second step is just basically using the formula. So not a lot of crazy stuff, but do expect something like this on your exam.